last class, we graphed a lot of quadratic functions by using tables. Today we're going to look at the patterns that we noticed and figure out ways we can graph them without having to make an XY chart every time. Here are the first 4 problems that you graphed using an XY table. And we discussed in class that they were moved up and down when things were added or subtracted. And that if it was inside, like x minus 1 squared equals y, that moved it right or left. But what we also noticed was the shape for all of these was exactly the same. We could move them around and they hadn't changed shape. The reason for that is we haven't multiplied our x squared by anything. The coefficient of all these x squareds is 1. And when the coefficient is 1, we know they all have the same shape. We're going to use that to our advantage. If we look at the first graph, this is the parent function, y equals x squared. And we're going to start at the vertex. To get to the very first point we plotted, we would go over to the right 1 and up 1, and there's our point. To get to the second point, we would go over 2 and up 4, and there was the next point. Well, if we look at the next graph over, starting at the vertex, here's our first point to the right. That's over 1 and up 1. Here's our second point. It's over 2 and up 4, just like our first one. If we look at the third one, here's our vertex. We would go over 1 and up 1, and there's a point. Over 2 and up 4, and there's a point. All of these have that same pattern. So once we know where the vertex is, if we know that the shape hasn't changed, we can plot those other points. They also all have, since we have this axis of symmetry splitting it in the middle, they have a mirrored point on the other side. Let's do this one. There's our axis of symmetry. This point here has a mirrored point here. So once we have half of it, this one's mirrored point is over here. All I need is this side, and I can graph this side by using those points. All right, we're going to graph y equals x minus 1 squared plus 2. This has been moved to the right 1 and up 2. So we're going to go right 1 and up 2 and plot our first point right there. The shape has not changed. Our coefficient is still 1. So to get our next point, we're going to go over 1 and up 1. To get the second point, we're going to go over 2, up 4. And then since here's our line of symmetry, we're going to plot our opposite points, our mirrored points. This one's here, so it's 1 away, so we're going to go 1 the other direction. This point is 2 away, so we're going to go 2 the other direction. Be sure you're using the axis of symmetry and not the y-axis. And then we can connect our points, and we graphed it without having to create an XY t-chart. Let's practice another one. We still have a coefficient of 1, so we know we have no shape change. This one has moved left 2 and down 1. So I'm going to go left, make this graph a little bit bigger. Left 2 and down 1 from the origin. There's my vertex. Now I can go over 1, up 1. Over 2, up 1, 2, 3, 4. What would the next point be? Over 3, up 9. So up 1, 2, 3, 4, 5, 6, 7, 8, 9. Now if we graph our axis of symmetry, which goes right through the middle here, we can plot our points that are mirrors. For this point, we have a point right here. For this point, we have a point right here. And for the point up top, that's 3, so we're going to go 3 the other way. And now we have 7 points. And there's our graph. And that's how you do it. As long as this is still 1, you're going to use that same pattern. Now, what if it's not 1? Here we have a coefficient of 2. Well, has this 1 been shifted? Is there anything added or subtracted? No. So we want to go ahead and plot. Our vertex is still at the origin, 0, 0. So I'm going to plot my point at 0, 0. Now, normally I would go up 1 and over 1. But everything is going to change by a factor of 2. Let's think about this. If we square 1, 1 squared is 1 times that 2 is 2. 2 squared is 4 times the 2 gives us 8. 3 squared is 9 times 2 is 18. What's happening, normally our points are 1, 1, 2, 4, 3, 9. What's happening to our y value? It's increasing by a factor of 2. All of those have been multiplied by 2, even though our x value is staying the same. So instead of going over 1 and up 1, we're going to go over 1 and up 2. 1, 2. This one, we're going to go over 2 and up 8. The third one won't fit on our graph, but we have our line of symmetry here, so we can plot our opposite points. We're going to have a point here and here. And you might notice this graph is considerably steeper than the other graphs. The larger your coefficient of x gets, the steeper your graph is going to get. All right, this one we have had a shift right and left. This has been moved to the right 1. So we're going to move to the right 1, and there's our vertex. And now everything's being multiplied by a factor of 1/2. So instead of going over 1 and up 1, we're going to go over 1 and up half of 1, which is half. Then it's not really an ordered pair. So over 1, up a half. Normally we go over 2 and up 4, but half of 4 is 2, so we're going to go over 2 and up 2. For 3, we go over 3 and up 9, but half of 9 is 4.5. So those are our new changes. This is our over, this is our up. So over 1, up a half, over 2 and up 2, over 3 and up 4.5. 1, 2, 3, 4.5. And then I'm going to do my mirrored points on the other side. Over 3, up 4.5. And then once we have all those points, we can connect them. And we notice that when you multiply by a factor between 0 and 1, so if this a is greater than 0 but it's less than 1, then that's going to make our quadratic open a little bit wider. What it's doing is it's pulling all of our factors, all of our y values down by a half. This used to be 1, this used to be 4, this used to be 9, and it pulled them all down. All right, and you have a worksheet to do to follow this.